Hey everybody, going to do a video to help remind us what's up with electrochemical cells. So this is not going to be like the problem that you have assigned exactly, but it will be similar, and hopefully you can use that to work on the one that I gave you. So let's assume that we have two electrodes, aluminum and zinc, and all they're really going to tell us is that the zinc is the one that gains mass. Now we know from earlier that reduction occurs at the cathode. And we know the anode is where oxidation happens. So if we're gaining mass, then our zinc is really going to go from a zinc ion to zinc metal. And so this is a reduction because the oxidation number goes from +2 to 0. So we know that the zinc is being reduced, and that is the cathode. So if they tell you that it gains mass, the one that gains mass is the one that's being reduced, which is the cathode. So when we come over to draw our picture, we got our two containers, we got our salt bridge, and then we have our electrodes. Now remember, the electrodes have to be connected by a wire with a little voltmeter. And it doesn't really matter which one you call which, but make sure when you draw the picture that both the salt bridge and the electrodes are below the level of the solution. So if I'm going to say that this guy right here is aluminum, then down here has to be my aluminum ion in solution. And if I'm going to call this one the zinc, then I need to say that in there is my zinc ion. Now, we know that the electrons travel through the wire from the anode to the cathode. So if the zinc is the cathode, then the aluminum has to be the anode. And so the electrons are going to go through the wire from the anode to the cathode. Now, everything that is negatively charged will travel the same direction. So when they ask you about the ions in the salt bridge, we know that the negative ions, like say the nitrate, it's going to go around the same way, clockwise. And the positive ions, the sodium or potassium, will go the other way. Remember, when you choose your salt bridge, you want things that are always aqueous so that they don't form solids with any of the solutions that we have. So always pick potassium nitrate or sodium nitrate. If they show you a close-up of the salt bridge tube and they want you to draw pictures, make sure you draw at least 3 of each inside there, showing which way they go. Don't just draw 1 of each. They like to see 2 or 3 of each. Okay, so one of the main things they always ask you for is E for the cell. And E for the cell is just E for the cathode minus E for the anode. So once we've figured out that the one that gains mass is the cathode, that's pretty easy. We look up on the chart that they give us the reduction potential for our stuff. So if we find zinc, it tells us that it's negative 0.76. That's the cathode. And then aluminum is the anode, and that is a negative 1.66. So our E for the cell is negative 0.76 minus a negative 1.66. So the difference there is going to be our E cell. Now, if you get a positive answer, then we know it's spontaneous and the reaction is going to happen, meaning it's useful. You can use the moving electrons to do work like power your cell phone or a flashlight or whatever. So positive voltage is good. So E cell voltage, same thing. Okay, so let's look at the overall reaction. So we have one reaction here with the zinc. Now the aluminum will look the same way on your reduction potential sheet, meaning that it's also listed as a reduction. And so the reduction potentials will be listed next to it. But when you do the overall reaction, remember it's redox, so something has to be reduced and something has to be oxidized. So if the zinc is reduced, the aluminum has to be oxidized. So we need to write it as an oxidation. So whenever you do the overall equation for the reaction, you're going to have to reverse the anode, or the one that gets oxidized. So we're not going to write it like this. We're going to write Al, arrow, Al3 plus 3E minus. Okay, now we can add those together just like we would do systems of equations or redox balancing, except you need to make sure the electrons cancel out. In this case, they don't. So let's get them to do that. So we're going to have to multiply so that we have a common multiple of electrons, which in this case is going to be 6. So we're going to multiply everything here by 2 and everything up here by 3. So then we'll get 3 and 6 and 3. And down here we'll get 2 and 2 and 6. So now the electrons cancel out and we can just combine these two things together. So what you're going to see is that you're going to have an ion and a metal on one side, and then on the other side it's just going to be switched around. The one that was the metal is now the ion, and vice versa. So we need our 3 zincs here. So that's the overall equation for the reaction, no electrons included. If you want to do line notation to show what happens in the cell, remember you start with the anode. And then you do a big tall line like that to represent a phase change. Then you show its solution, the ion in solution. A double line represents the salt bridge. Then on the other side of the salt bridge comes out into the other ion. And then finally, the last electrode. So anode first, and then cathode over there. Same direction as the electrons go through the wire. Really, the only time that's different is if you want E for the cell, and then you just do cathode minus anode. So look for the reaction and find the thing that gets reduced. You can pick out the cathode that way. You can find the thing that gains mass, or if you just have them listed on a reduction potential sheet, the one that's higher up on the list is the one that's reduced, and therefore it's the cathode. So hopefully that reminds you of some things, and you can use that to work on that problem that I gave you. A little bit different, but really they're all kind of the same. So look for the similarities, and then you can probably work out the differences. So give that a shot. Let me know if you need more help. Send me a text, email, whatever.